Welcome to SND College of Engineering and Research Center, Yola, Department of Applied Science online lecture series. Today we will discuss about subject engineering physics, unit first wave optics, and first topic interference. Before start video, we will brush up our knowledge. So what is interference of light? When two or more waves with constant phase difference, same intensity and same amplitude traveling from medium, each wave produces its own displacement irrespective of each other. The resultant of this wave is the vector sum of the amplitude of each wave. The modification or the redistribution of intensity of resultant wave due to superposition of two or more waves is known as interference. There are two types of interference: constructive interference and destructive interference. So constructive interference is when the crest and trough of one wave coincide with crest and trough of another wave, then resultant intensity become maximum, and this is constructive interference. Destructive interference, when the crest of one wave coincide with trough of another wave, then resultant intensity become minimum, and this is destructive interference. In previous video we have already learned some topic, just introduction to electromagnetic wave and electromagnetic spectrum, interference in thin film of uniform thickness, interference in wedge shaped film also known as interference in non-uniform thickness. So today we will discuss about application of interference. There are two application of interference. First one is testing of optical flatness of surface, and second one is non-reflecting or anti-reflection coating. So first one is optical flatness. Flatness of surface is measured using optical flat plate and monochromatic source of light using the principle of interference. When an optical flat, also known as reference plate, and a work surface, that is test plate, are placed in contact, an air wedge is formed. The one plate is placed to surface and second is test plate are placed in contact and air, and this form of wedge. When monochromatic light is incident on the optical flat, we get alternate dark and bright fringes, also known as interference fringes. The change in thickness of the air wedge will dictate the shape and orientation of the interference fringe, and their shape gives a visual representation of the flatness of the surface being tested. Straight, parallel and evenly spaced interference indicate that the work surface flatness is equal to the reference surface. If band curve towards the line of contact, the surface is convex. Similarly, if the band curve is in the opposite direction, then the surface is concave. This is first application of interference, testing optical flatness. Second application is anti-reflection coating or non-reflecting. The anti-reflection coating is used in cameras, projector, lens, telescope, etc. to reduce loss of light by reflection. On the screen you have to see one figure. When light falls on the camera, it gets reflected from upper and lower surface of anti-reflecting coating as shown in figure. Ray R1 is reflected from surface of coating ray, and ray R2 reflected from the surface of the lens. Due to destructive interference, the intensity of reflected rays reduced and thus reflections can be generated. The condition for minimize 2 mu c cos of r is equal to lambda upon 2 and 2 mu c t is equal to lambda upon 2. Therefore, t is equal to lambda upon 4 mu c. Then anti-reflection coating, phase shift between the beam reflected at the upper and lower boundaries of a thin film is 180. Destructive interference between the two reflected beams occurs. The optical thickness of the optical coating must be an odd integers multiple of lambda upon 4. Odd integrals multiple then lambda upon 4. The optical thickness of anti-reflection coating can be measured. So I hope student you have understood this application of interference. Thank you.